So let's talk about dividing. Dividing is essentially going to be the same steps as fraction or as multiplying, but the first step is different. When you divide fractions, remember you want to flip the second fraction first and then change the sign to multiplication. All the other steps now stay the same. So let's see what this looks like. This means this fraction stays the same in my problem. I'm just going to rewrite it. This second fraction gets flipped. So this changes to 4a squared plus 12a all over a plus 5. And notice again, I changed it to multiplication. Now let's follow those same steps like we did before. I'm going to factor the first numerator by taking out a GCF. So it's going to be 3 times a minus 4. I'm going to factor this guy. Let's see, we could do a minus 4 and then a plus 3. I can take out a GCF here, which is going to be 4a, which is going to leave me with a plus 3. And then I've got a plus 5 as my denominator. So let's start crossing some stuff out. A minus 4's cancel. A plus 3's cancel. Now notice I have 3 and then 4a in my numerator. Those get multiplied together to give me 12a all over a plus 5. I want you to try a division problem on your own, and when you're ready, hit play to check your answer. So I'm going to keep that first fraction the same. I'm going to flip this one, rewrite it as x squared minus 9x plus 14 all over x squared minus 5x plus 6. Now I can't do anything with this first fraction. It's going to stay the same, but the second fraction, I can factor this into x minus 7, x minus 2. And then I can factor this next one. Let's see what multiplies to give me a positive 6, adds to give me a negative 5. I can do an x minus 3 and then an x minus 2. So now I can cross out my x minus 2's here. I can also cross out, so keep in mind that special case, x minus 7 and 7 minus x, those do cancel each other, but you have to bring a negative out front of your final answer if it's written backwards in its subtraction. So my final answer would be negative and then x plus 2 all over x minus 3. Now let's talk about addition and subtraction. Now, if you have rational expressions and the denominators are the same, wonderful. You can keep the denominator and then just add or subtract your numerators. This is only when the denominators are the same. You always want to simplify your final answer if you're able to do so. So like in this case, if my denominator is the same, just keep it the same. I can't actually add x plus 5, but I can just rewrite it as x plus 5. Now, keep in mind, this is one entire term, so can I cancel anything? No, I can't. So that would just be my final answer. Subtraction is where you have to be very careful. So anytime a student is approaching a subtraction problem, I always tell them, like, put a star beside it, make a little note about it, because what happens with subtraction is you're not just subtracting x, you're subtracting x minus 3. So that subtraction symbol essentially gets distributed to everything in your numerator. So watch how I rewrite this. My denominator stays the same. I rewrite my numerator as 2x plus 4. This is going to be minus x. And then what happens to this last one here? A negative times a negative turns this into a positive 3. So just make sure that subtraction symbol gets distributed to everything in that second fraction here. Now I can definitely simplify this. I can rewrite this. I'm going to rewrite it down here. As 2x minus x is just x. 4 plus 3 is going to give me 7. And this is all going to be over, let's see, x squared plus 13x plus 12. Now you do want to always check to make sure that this fraction in itself can't be simplified. So if we wanted to check that, we could factor our denominator, which gives me x plus 12 and then x plus 1. So notice that didn't really help me because I don't have another x plus 7. So either way you write your answer in this case, whether it be this way or this way is still correct. But again, you always want to check to make sure that nothing can be simplified here. So pause the video, try one like this where the denominators are the same on your own, and when you're ready, hit play to check your answer. So I'm going to just rewrite my denominator, which is x plus 3. I'm going to be very careful since this is subtraction, and I'm going to make sure I share that subtraction with everybody here. So this is going to be 2x squared plus 4x minus 3. It's going to be minus x squared. It's going to make this guy a positive 2x. It's going to make this guy a positive 12. So let's combine some like terms here. 2x squared minus x squared is just x squared. 4x plus 2x is 6x. Negative 3 plus 12 is going to give me a positive 9. Now this is not simplified, because think about it. If I factored this numerator, it's going to be x plus 3 times x plus 3 all over x plus 3. So I can't cancel all the x plus 3's, but I can cancel a pair of them. So if I cancel a pair of them, I'm just left with x plus 3 as my final answer. Now, how do we add fractions with unlike denominators? So let's first think way back to when we were adding fractions, no variables, just regular fractions, and they didn't have the same denominator. Kind of go through your steps here. Remember, step 1 is you got to find that common denominator. So what is a common denominator between 5 and 8? It doesn't have to be the lowest one, just what's any common denominator. Well, they'll both go into 40. So remember, your first step is once you find that common denominator, you want to rewrite your fractions with the common denominator. How do we do that? So remember, the step you do is, how did I go from 5 to 40? So whatever you did to go from 5 to 40, which in this case is multiplied by 8, you got to do the same thing to your numerator. So 8 times 3 is going to give me 24. Rebuild this fraction as well. I'm multiplying by 5, and so 1 times 5 will just give me 5. Then you want to add. So we would add these two. 24 plus 5 would give me 29 all over 40. And then if you can, the last step is to simplify. Now 29 over 40 can't be simplified, so this would be my final answer. How does this apply to what we're about to do? Well, the first thing we got to do is figure out, how do I find my least common denominator of a little more complicated fractions? So some of these rational expressions that we've been dealing with. Now, if you just have numbers and variables involved, for numbers you can use a variety of methods. What I particularly like to do is I like to take the highest number, and then you remember kind of making a list of all the numbers that that highest number would go into. So let's take a look at like this example here. 39, I could do 39 times 1, which is just 39. I could do 39 times 2, which would be 78. I could do 39 times 3, which would be 117. I like to go maybe 4 or 5 numbers out. So if we did 39 times 4, which would be 156. And let's just do one more just to be on the safe side. 39 times 5, which would be 195. And then you go down this list, and we're trying to figure out another number that, or one of these numbers that 12 would also go into. So 12 won't go into 39, so that's out. Like, okay, does 12 go into 78? No, that's out. Does 12 go into 117? No. Does 12 go into 156? That's my winner. So 12 would go into 156. So when we're coming up with that least common denominator, we know 156 is a number that both 12 and 39 would go into. Now, in terms of your variables, all your variables have to be listed that appear in both of these. So in this case, X would have to be listed because it appears in one of them. Now, if they have the same variable in common, this is a little bit different than GCF. We pick our highest exponent. So in this case, my highest exponent would be y to the third. So my final least common denominator would be 156xy to the third. Now, I will say your graphing calculator can help you out with the number piece of this. So if you go to math on your graphing calculator and you scroll over to num, you should see LCM listed there. If you hit LCM and you put in 12 and 39, then it should give you 156. let's talk about what it means to build equivalent fractions. So let's go through that same process here. I got to come up with that LCD first. Now, what is a number that both 18 and 27 will go into? So just for the sake of time, 54 is a number that both of them would go into. X to the third is my highest x. Y to the third is my highest y. So this would be my least common denominator. So we would draw our fraction bars and put that least common denominator at the bottom. Y to the third. I'd put 54, x to the third, y to the third at the bottom. Now, how did I go from 18 to 54? Well, to go from 18 to 54, you are multiplying by 3. So whatever you do down here, if I have to times this one by 3, I have to times this one by 3 as well. So 1 times 3 gives me 3. Now let's look at the variables. What did you do to go from x to the third to x to the third? Well, you did absolutely nothing. So nothing happens with my x's. But what did you do to go from y to the third? You multiplied by y squared. So since I multiplied this by y squared to get down here, I got to multiply my numerator by y squared as well. Now let's rebuild this one. 27 times 2 is what got me 54. So I got to multiply this one by 2 as well. X squared to x to the third, you're multiplying by an x, so I got to multiply this one by an x as well. I didn't do anything with my y's, so that stays the same. So 5 times 2x is going to give me 10x. So my final fraction would be, my denominator stays the same, it would be 3y squared plus 10x. Now I can't factor my numerator, so this is in simplest form. Now, what about if you don't just have a single monomial, that maybe you have multiple terms? You do want to make sure that you factor each denominator into prime factors. You want to write the first denominator down. So let me show you an example of this. Let's say you had two fractions and the first denominator you factored it into x plus 2 times x minus 3. And let's say the second fraction you were able to factor it into x minus 3 times x plus 5. So again, factoring is your first step. When you're looking for the least common denominator of fractions such as these, you always write down the first denominator in its entirety. So there's my first denominator. Then you look at each additional denominator and write down any new factors that did not appear in the first one. So here's my first denominator. Let's glance over here at the second fraction. Is there anything new, essentially? Is there anything that wasn't covered over here? Well, notice this one has an x plus 5. So x plus 5 would also be a part of my least common denominator. Once we get that least common denominator, we're going to rebuild those fractions. So we'll do that step in just a minute. Let's first just talk about how to find the least common denominator of these. So in this example, again, you'd want to factor first. Factoring is never going to go away. This one I'm going to factor into x minus 4 and then x plus 3. So what would my least common denominator be? I'm going to write down my whole entire first denominator. Glance over here, is there anything new? Well, yes, x minus 4 would be new. So my whole entire common denominator would be x plus 3, x minus 1, x minus 4. So let's look at this guy. Let's factor this one into x minus 5 times x minus 5. I'm going to factor this one into, let's see, this would be x minus 9 times x minus 5. So I'm going to write down my whole first denominator, which is x minus 5, x minus 5. Does anything new appear over here? Yes, x minus 9. So this would be my LCD of the whole thing.